Okay, yeah, welcome everyone. This is Chris Fregley, and we've got Antje Barth from Dusseldorf. I'm based out of San Francisco. I've been running this webinar for actually a few years now, so lots of you already know me. You very likely know Antje. And we have a special guest with us today. So Philip Schmidt out of Nuremberg. And one of the places I've always wanted to go in Germany, but still haven't been. I want to rent a Porsche and drive it out there, Porsche. So yeah, Antje, do you want to say hi, and then we'll get Philip to say hi, and then I'm gonna do some sort of intro catch-up things since the last time that we met, and then I'm gonna hand it over to Philip, who's gonna talk about serverless NLP. So yeah, Antje, why don't you say hi?
Sure. Hi, everyone. Yeah, as Chris introduced me, my name is Antje Barth. I work as a developer advocate for AI and machine learning at AWS, and I'm based in Düsseldorf, Germany.
Yeah, Philip, do you want to introduce yourself? And then
hi, my name is Philip, and I'm from Germany too, and I live in Nuremberg, which is the second biggest city of Bavaria. So it's pretty close to the Oktoberfest, and later I'm going to show you how to implement BERT in a serverless way.
Yeah, so pretty exciting. I'm also going to paste links, so I'll paste them into the Slack channel if you've just joined. Maybe Antje, can you keep an eye on the chat and keep pushing people to the Slack?
Will do.
And what was the name of your talk, Antje, that I'm going to share here?
It's the deep dive on BERT and also visualizing BERT attention. Good fit for today's topic.
Yeah. Okay, so let me, here's Antje's talk that we might not have time for today. So that one she had done recently got really, really good feedback and lots of great attention from the community on that. So that one's good. Let me send a quick link here to the quantum talk, which I might touch on briefly here. I also want to share this other one called Waking the Data Scientist at 2 in the morning. So I'll paste that into the Slack here as well too. And I'll save Philip, I'll send his link here when he is about to speak, but let me pull one of these up here. So for example, that's the quantum one. Everyone seems to like the quantum one. So let me open this up here. And this is very, very low resolution. I have the original somewhere, but I'm just gonna skim through this. Oh, this is really bad resolution. Oh, that's a bummer. Make it a little bit smaller. So, oh, and then I should also quickly plug too that Antje and I are working on a book. We've been working on this for the better part of the year this year. We're on the final stages of it. Now that the content from reInvent, the big Amazon conference, is starting to be finalized and new services are being released. In here, you'll see a link to our book here. It's actually available for pre-order. And if you wanted to click that, and that would be great. Otherwise, we've got this workshop. We've currently postponed the workshop. We do a full day workshop. We're currently postponing it until early 2021. We wanted to take a break and rebuild lots of new content around these new services. You'll see we do have quite a lot of, so here's the link for that. Here's the link for the book. And here's really, a lot of the content that we've been building for the book. So this is our workshop repo that actually powers the workshop, the full day workshop up above. We do encourage you to come to the workshop. We cover lots of great content. The total cost, if you were to do the workshop on your own, if you do it with us, we actually pay for it. We will give you your own Amazon account or credits or some way that you don't have to actually pay. But this whole workshop end to end is $24, and we cover lots and lots of material. Obviously, we're not taking the money that goes to pay for the services behind the scenes, but we do lots and lots of stuff, and it's a really fun one. There's also this YouTube channel here for all of our past stuff. There's this webinar series that you all are on today. And let's talk just real quick about some quantum stuff. I actually haven't done this talk in a few months, so I'll zip through it here. But this particular talk, we discuss what is quantum computing, what are some of the use cases. We talk about the common terms like QPUs. You can think of these as processing that is detached from from your motherboard or separate from your CPU. So similar to how you might use a bank of GPUs or a separate card that you install into your data center servers, you would have to access them sort of off CPU chip. We talk about common terms like what is a qubit, what's superposition, entanglement, teleportation. We've got a blurb on how to program QPUs. And then at the end, which we're not going to do today, but these are in the workshop, are the quantum notebooks, the like Jupyter notebooks that you can fire up with the Amazon Braket service, which has Jupyter and has all of the like quantum computing libraries pre-installed for Python. And it's super fun. You could do simulators. You could get access to actual physical QPUs from companies like Rigetti, like D-Wave, like IonQ. And we'll start to see a lot more quantum computing in the next few years, especially now that this is now part of the Amazon service. So I would recommend this book. I actually went through it real quick a few days before building this presentation. It's called Programming Quantum Computers. I think I actually have it physically right here. If you got the camera on, you can, if you see my video, you can see it. So combining that with a lot of research and with my background in physics as well, I was able to really like distill quite a lot of this down, and I somehow jumped ahead here. Get back. And one thing that I always forgot, or I remember thinking when I learned it, but had since forgotten since college, is that Einstein actually called these like this whole quantum mechanics to be spooky. There's no reasonable definition in reality that could permit quantum mechanics. So, you know, really fun stuff to learn about. So why quantum now? There's huge long-term potential. We at like Amazon want to expose these services to you, these QPUs to you, so that you can learn and then build expertise now and be prepared. Some have said that people learning quantum computing today will be some of the most valuable like programmers and managers and like development managers for the future. Just trying to understand this whole computing paradigm. Right now, it's the equivalent of sort of deep learning in its early phases. It's the equivalent of really low level sort of bytecode or down to the registers. You really have to think about the physical hardware. So it's not necessarily the most fun programming environment, but when you can massively parallel at sort of nature's operating system, which is quantum mechanics, this is very, very powerful, can tackle lots of very large scale problems that are just not even possible today with classic computers. And there's something, if you ever hear Jeff Bezos talk or some of the senior execs from like Amazon or like AWS, they are always talking about flywheels. This is how the entire Amazon.com model was built with the marketplace, with like the ability to lower prices, offer more products, keep the flywheel growing, add more customers, all that stuff. So that's really what this whole Braket service is all about by Amazon. So okay, and you'll hear lots of people talk about the NISQ era, which is the current era that we're in. So the first era of quantum computing was the classic simulatable. That's sort of this green area here. We have now entered, so that's just proving that this could work. Now we're actually running real jobs on quantum computers. It's very noisy. We need lots of like error code detection, or sorry, error correction. And so very similar to how we used to have to do error correction, or still do, but still with like RAM chips, things like that, where we needed to do extra processing to perform that like error correction. Right now, we are still being dominated by the like error correction. So if we had a a 50 qubit system, 47 of those go, or some large percentage of those qubits actually go towards the error correction, which sort of limits the scalability a bit. Hopefully we will enter into phase 3. Maybe, people say 5 to 10 years. They've been saying 5 to 10 years for the last 15 years. But we will hopefully soon be entering the third phase here, which is error corrected quantum computing. And that's where we'll really start to see a step up. You might hear the term quantum supremacy. That's really where we transitioned from phase 1 to phase 2 into this NISQ era. And this was made famous by Google back in, just recently actually, back in like 2019. So now we are at the very beginning stages of this NISQ era. So, and here's the service, really where it's, think of it just like Jupyter notebooks, and you have access to GPUs, but these are called QPUs. And they are very asynchronous. And so you have to launch something to run on the QPU and then sort of wait for it to finish and then get it back. And some of these jobs might take 1 day to actually get scheduled, just because you are in a pipeline. Think of the old days when we were sharing, large like supercomputers in school, or back in the old days, sharing large mainframes, things. So you are submitting jobs, and then they run on that hardware, that like quantum hardware, and then you get those results back. And so these are the 3 providers that Braket fits in with today. We might be seeing more of those, hopefully. And here's some of the use cases. So obviously cryptography is driving quite a lot of quantum computing. In fact, the quantum computing group within Amazon actually stemmed from a cryptography project that was started a few years ago to really stay ahead of what's going on here. Quantum computing has the capability, not right now, but in maybe 10, 15, 20 years, to actually break all of RSA current, the like 2048 digit keys. So right now we have very large keys for our cryptography, which takes classic computers a really long time to break. But once you can like open up to the quantum, the super highly parallelizable quantum computing, we can break these in like just under a minute. So this is very, very scary. Without quantum, so here it says 3 minutes projected. Without quantum, trying to break one of these could take, millions, quadrillions of years. So we weren't really thinking about it until we started like catching wind of what quantum computing can do. So that group is now the Braket group, and they're the ones really are driving lots of these use cases. Some of you might be asking, well, okay, how does this relate to machine learning and deep learning? And to be honest with you, right now, the like applications for machine learning on quantum are quite limited. And you could do basic linear regression, you could do PCA, you could do, support vector machines, fast Fourier transform, systems of equations, pretty bare and sort of classical machine learning. But people are starting to try out more algorithms. There's huge like exponential speedups for these classes of algorithms. But really, quantum shines when it comes to simulations, these material science simulations, drug simulations, financial simulations. I know I think I mentioned it later, a very public use case by Fidelity, who has an advanced computing group who is simulating options markets and making some cool gains there. So looks like we got logistics here too. I found this one website to be really, really cool. It's called the Creative Destruction Lab. And looks like they fund about 20 or so quantum machine learning startups per year, among other startups. So yeah, check it out. It's called Creative Destruction Lab. Here's the Fidelity use case. Sorry, this is hard to read. Let's see. Yeah, they're using Braket to try out various simulations. Volkswagen's using it for the 2 German hosts that are on right now. This should be very interesting, although this is Volkswagen of America. But they're using it to try out different, let's see, where they're using it for. It's hard to read there. Yes, Amgen's using it for biotech, and a few others here. So I'm not going to have time to go into the rest of this, but this explains QPUs, some of the error correcting, some of the quantum mechanics behind this, what superposition is, the circle notation that you'll see in this book that I showed here. Also some more of the use cases here. So for example, we would need 6,000 qubits to break the 2048 RSA, but keep in mind, those are 6,000 clean qubits, non-error correcting qubits, which really ends up being 1 million total qubits, including the like error correcting qubits as well. So still like quite a ways away, because right now we are at about 70 qubits, maybe maybe 100 qubits is possible today, but to get to this 1 million with the like error correcting, still like quite a ways away. So the entanglement's really cool. It's essentially a form of like teleportation, where we are moving information, not matter, by the way, not mass. We are just like transporting information. So think of it like nature's sort of Ethernet cable. And I think we're at 20 minutes there, so I'm gonna hand it over. Philip, are you ready to go? Do you want to share the screen?
Yes.
Okay, so Philip's gonna talk about serverless BERT with NLP, and he's got one blog post that we found, and he just finished one blog post, I believe yesterday. He's gonna share with us the latest and greatest. So, all right, Philip, go ahead.
Okay. So big thanks to Chris and Andy for giving me the opportunity to talk today. And I will present you my serverless BERT solution. And we are going to use the transformers library from Huggingface, AWS Lambda, and the Amazon Elastic File System. Yes, first I will introduce myself to you, who I am, what I do for a living, and explain a bit why I built a solution. After that, I will briefly explain what is serverless and which AWS services are serverless. And then I will explain the language model BERT a bit, very high level, and explain how it was trained. And finally, we implement my solution together. Yeah, now to me, my name is Philipp Schmid. I live in Nuremberg, Germany, which I already said is Nuremberg is the second biggest city of Bavaria. Currently, I'm working as a machine learning engineer at a technology incubation startup. And at work, I design and implement cloud native machine learning architectures for fintech and insurance company. I started to work with AWS in 2016. I have a blog where I mainly write about NLP and cloud stuff. And on Twitter, you can find me at _PhilSchmid. So you probably ask yourself, so, okay, why serverless BERT? And I was thinking about how to deploy a BERT model in an affordable way. Usually it's very hard to host big language models like BERT, Roberta, or GPT-2 due to its size and computation power you need. It's also very expensive to run such model if you don't have like requests coming in 24/7. So this leads to the fact that you cannot implement small MVPs or test things out. For me, the solution to this was to leverage all the serverless benefits and build like a serverless BERT APIs, which you can use for testing. So what is serverless? I'm not sure how many of you are familiar with serverless or the serverless concept. I always describe it as follows. Serverless is a cloud native execution model for short running stateless computation and event driven application, which automatically and instantly scales out and in and charges only for the actual usage. Or you can say it's like the dream of modern development. Many people often understand serverless as fast, a function as a service, or often think like serverless is equal to AWS Lambda. But AWS now offers more than 10 different services in all relevant areas, from messaging like SQS and SNS over network with API gateway to databases and storages as serverless services. One of the latest additions is TimeStream, which is a serverless time series database. And where I work, we already use it for a productive application to measure carbon dioxide in classrooms for COVID. So we built a small application which tells the teachers when they have to open the windows. So now that you have a rough understanding of what is serverless, we can talk about BERT. BERT was published in 2018 from Google and stands for Bidirectional Encoder Representations for Transformer, and is designed to learn word representation or embeddings from unlabeled text. BERT is kind of special because it learns the information from both the left and the right side of the token's context, as you can see here on the right side, and is trained on the entire English Wikipedia and a large corpus of books. BERT was trained in two ways. On the one hand, with the mask language modeling method. This means like 15% of our data set from Wikipedia and the book corpus, where the words are replaced with the mask token, as you can see at the top. And BERT learns then to predict this token. This means BERT reads the sentence, the doctor ran to the emergency room to see patient, and then learns how which word he can or it can replace the mask token. In this case, it would be his. So the doctor ran to the emergency room to see his patient. On the other hand, it was trained with the next sentence prediction method. This means BERT receives a pair of sentences like sentence A and B, and then learns to predict if the sentence B is the following sentence of A. So if we have, in our example, the man went to a store, he bought a gallon of milk, BERT predicts, okay, is sentence B a following sentence of sentence A from the context? And in this case, it is the next sentence. So what can BERT do? BERT offers a possibility to use it versatile. You can use it for sequence classification like text classification or sentiment analysis. You can use it for solving multiple choice problems, or you can use it for token classification like named entity recognition. Or you can build a question answering system like we are going to do next. So now we are at the interesting part of our talk, the implementation of the serverless question answering API. We are going to create our infrastructure using Terraform. Terraform is an infrastructure as code tool from HashiCorp. Afterwards, we install and sync our Python dependencies to our Amazon Elastic File System with EFSync. Then we create a Lambda function with the serverless framework, implement our BERT model. In this case, we use already fine-tuned mobile BERT from Google. And last but not least, we deploy our serverless function and then test it. The architecture we are going to build will end up looking like this. So we have our user, which sends the context and the question to our API gateway. The API gateway passes the request to our Lambda function. The Lambda function then loads our Python dependencies from our Elastic File System, uses the mobile BERT we implemented, and predicts the answer for our given question and context. So I will link my blog and the GitHub repository at the end, or Chris already shared it in the Slack group, so you can sit back and enjoy the implementation. The first step where we have to do is to create our Terraform templates. Therefore, we create a directory Terraform with a main.tf file in it. main.tf is like HashiCorp built a file system and language to create like Terraform modules. This is all the resource we are going to need. At first, we have like a provider which describes, okay, which region we are going to use and which credentials we are going to use. I created an IAM user for the complete article, so it's easier to re-implement it. Then we use our default VPC with our subnets, create our Elastic file system with the name Serverless BERT, add an access point to it, so we can use it in our Lambda function, add mount targets to it so we can mount it. I also expose our access point ID from our Elastic file system as system manager parameter, so we can use it later easily in our Lambda creation process. To use Terraform, we go to the directory and then run Terraform init, which then loads our provider, in this case, AWS. After it's loaded, we can use Terraform plan. Terraform plan like checks all our resources and give us expectation what we are going to create. Here we can see, okay, we are going to add 6 resources, change 0 and destroy 0. To create these resources, we simply would run Terraform apply. But now we are not going to do this because this takes around 2 to 3 minutes and we only have limited time left, and I already prepared this before the talk. So we imagine we have our infrastructure deployed. The next step would be to install our dependencies to our new freshly created Elastic file system. To do this, I created a tool called AFSync, which simply starts an EC2 instance, then mounts it to our Elastic file system, install the dependencies to this mount point, and stops the EC2 instance and terminate it again. To use it, we install it with pip3 install AFSync, which shows, okay, I have already installed it. And to use AFSync, we have to create an YAML file which holds all the configurations. The configurations you need are like the Elastic file system ID, which we created earlier, our subnet ID from the VPC, or subnets, which is where our Elastic file system is running, an EC2 key name, and a few more additional informations like, okay, which Python version we are going to use later, what is the mounting directory, and which requirements are going to use. And therefore we need a normal requirement TXT file where we include our Python dependencies, which we want to use in our Lambda function later. For this example, we are going to use the CPU PyTorch version 1.5 and the transformers version 3.5. After we added this, we could run AFSync with one CLI parameter with the path to our configuration files, and then would start our EC2 instance, install our dependencies, and stop it again. We also not going to do this because it takes around 5 to 10 minutes, depending on the Python package, which you are going to install. So I already prepared this tool. So now we can imagine, okay, we have our infrastructure created, our Elastic file system. We have installed all the Python dependencies we need. The next step is to create our Lambda function. Therefore, we use the serverless framework. The serverless framework is a framework which helps you to create AWS Lambda functions in a very easy way. It handles for you all the zipping and uploading to AWS. To create a Lambda function, we simply run serverless create. We can add a template and a path where we want to create our function. After that, we can see, okay, our function is created. It created a handler.py with a few boilerplate codes and a serverless.yaml, which defines all the configurations for our Lambda function. Okay, now we have our Lambda function ready. We have our infrastructure ready. The next step we are going to do is to download our model from the Transformers hub and then integrate it to our serverless function. Therefore, we go to our functions directory, create our model directory, create a Python file.
Hey, so Philip, can you actually zoom in quite a bit?
Sure. Yeah.
Awesome. Thank you.
Is that okay?
As much as you can. Yeah, it looks like you got a lot of black space there. So yeah, zoom. Yeah, just
okay.
Yeah, make it as huge as you can. Thanks.
In this Python file, we are going to download our models and tokenizer from the Transformers hub and save it in our model directory. Be careful, if you want to download it, you need Transformers installed locally, not only on your Elastic file system. So now we can simply run Python 3 and then get model, which will then download our mobile BERT into our model directory. Yep, it worked. We have our configuration. We have our bin file, which was the model and all the tokenizer configurations. Okay, we have our environment set up. We have our models. The last step we need to go is to implement all in our handler.py. So I created all the code earlier and we'll go through it a bit. The first thing we need to do is to add our Elastic file system volume to our Python path so we can use all the dependencies we installed to it earlier in our Lambda function. Therefore, we could simply add civ.path and add our EFS path to it. I created an environment variable which we are going to define in our serverless.yaml. Afterwards, we import all the required Python dependencies we need. I created an encode function for our question and context, a decode function for our answer, and then created like a function which initializes our model and tokenizer and returns a predict function we can use in our real handler function. We also are going to initialize the serverless pipeline, our question answering pipeline before our real handler function, because if we initialize it, it only runs once until the function goes, or you have to restart it again. So if we would implement it in the handler file, it would initialize it every time we request our function. If we initialize it out of the scope from the handler, it initializes only once if you send multiple requests. In our handler function, we load our JSON request body, then use our question answering pipeline, give it our question and context, predict it, and then return the output to our user back. And there's just an exception handling if something goes wrong. The last and final step we need to do is to adjust all the configurations. In our serverless YAML, we define all kinds of configurations we have, like we define our Python runtime, our region, the memory size. We also can add environment variables, IAM policies we need, exclude some packages we don't want to include, and add like our EFS file system, our VPC and subnets, and also add the events which will listen to the AWS function. And here you can see we have our system parameter added, which we created earlier in our Terraform templates. So it's pretty easy to use. We also need to add the serverless pseudo parameter. They are used to get our account ID to it. Either you can install it and use this pseudo parameter, or you can add it manually, like with the 11 characters it has. So therefore we need to install it, and we are good to go. The next step is simply to deploy our serverless function by running serverless deploy at our AWS profile and wait till it's ready. This would take around 1 to 2 minutes because the model we are going to add is around 58 megabytes. So maybe there are 1 or 2 quick questions we can answer.
Yeah, so I have a question actually about this serverless package. So I was following along your previous blog posts back when we first got in touch with you, and I wasn't actually familiar with the serverless thing. So Antje said she's used it before, but can you talk about why you chose to use the serverless and what would be the other options? I know there's the SAM or the SOM or whatever for to actually deploy. So the use case here is to deploy the Lambda with nice like quick commands.
Yeah, I use the serverless framework because when I started using AWS Lambda, SAM wasn't even announced, so it wasn't there. And I like the serverless framework because you can, I mean, it's simply the same as SAM, only you have like different configurations in your YAML file. And what's also nice, you can, the serverless has a big environment with a lot of plugins. There are plugins for installing Python dependencies directly into your Lambda function. You can create layer. You can create custom serverless plugins to run like a script before your deployment afterwards, or you can even add like AWS resources with CloudFormation templates directly in this YAML.
Gotcha. So if people were to do this today, they could potentially use SAM, or if they're already familiar with it. Okay.
Yeah, if SAM provides the possibility to add your Elastic file system to your AWS Lambda function, sure, you can use it.
Gotcha. Okay. Thanks. So where did you spend the most time when you were putting all this together? Like, I assume that the BERT stuff was probably the easiest, and then now going to productionize it became the real challenge.
Yeah, the hard part, or why I reworked the whole article, was like it is very hard to add all the Python dependencies like PyTorch or Transformers or TensorFlow to your serverless function, because AWS Lambda or Google Cloud Function always has like size limits. In AWS Lambda, you have like 250 megabytes of size you can use for your Lambda function, and PyTorch alone is like I guess 700 megabytes or something like that. So this was the hardest part. And in June, AWS announced a feature you can mount your Elastic file systems to your Lambda function like you do it in Docker. For me, this was the step to go and create like AF Sync, where you easily can transfer and install your Python dependencies on this volume, because currently AWS has no managed service to like serverless install your dependencies. You can use like data sync, but there you need a running EC2 instance, or you can do it manually by hand by starting up an EC2 instance, then mounting your file system to it and installing them. So I went to to automate all the process. Okay, since our Lambda function is deployed, we can test it. You can use like any REST client you want, Postman, Insomnia, can you even use a simple curl. I prepared some context from a BERT snippet with a question, what is BERT? And simply can send my request. The first time we sent our request, as I explained earlier, our Lambda function has to mount our Elastic file system to our runtime and then has to initialize our model. And the biggest current problem in this solution is like initializing and loading the model. It takes around 15 to 20 seconds, which results in many cases the function will time out. But what isn't a problem, because if I send my request again, it has initialized the complete request with loading, mounting, and initializing the model takes around 29.3 seconds, and the timeout duration from API gateway is like the same. So it's kind of tricky to get it to run, but this will be the next problem I'm going to work on. Maybe we can improve it by loading it directly from an ONGS file or using Torch script. So as you can see, our model returned our answer. In this case, it was bidirectional encoder representation, which is correct, I would say. We can also ask it another question, like what is the clue score for BERT? And it's like 80.5%. And as you can see, the request only takes around 800 seconds because our model is already initialized. Our AWS Elastic file system is already mounted. And if you don't want to have like this very, very long code start, you can also implement like some warm up requests where you send like every 3 to 5 minutes a simple dummy request to your function, and you have one concurrent runtime always up. Okay, that's it for my live coding. I will go back to the presentation. And thank you for listening. And I have 2 QR codes you can scan. The left is going to bring you to my blog with the article, and the right one will bring you to the GitHub repository with all the implementation and all the code, with an extra additional tutorial what steps you have to go to deploy it into your AWS account. Thank you.
Great job, Philip. Very, very interesting. And you helped me understand how we were going to get past the larger model size within Lambda. I realized with the EFS stuff, because we noticed that with your previous version, it looks like you were using a model that was 230 meg, maybe, which fit under the 250. So.
If you last time I used distal BERT, but I switched to mobile BERT because otherwise it would take like 1 or 2 minutes longer to deploy it, and we only have a limited time left. And if you want to, let's say, use a GPT-2 model or a Roberta model in your AWS Lambda function, you can use EF Sync to sync your model files from an S3 bucket into your Elastic file system, and then load it from there in your AWS Lambda function.
Great. Okay, let's see, do we have any questions here? Let me double check. If anyone has questions, okay, how do you get the Postman URL to your Lambda? So I assume it's a question.
Wait, I'm going to show. If you deploy your Lambda function using the serverless framework, if you run serverless deploy, at the end, you get like service information with the name, with the stage, with the region where you deployed it, your stack, and also the endpoints. if you don't use serverless framework, I'm not sure what Sam is going to put out, but you can always check your AWS console for your Lambda functions, and there you can find your endpoint or even your API gateway.
Gotcha. Okay. Oh, so is the serverless setting up an API gateway?
Yes,
the scenes?
it is. Yeah,
Gotcha.
the serverless framework is setting up an API gateway because we defined in our serverless framework here under events an HTTP event. You could also define like an SQS event or an S3 event. With the serverless framework, you can define all AWS Lambda trigger you have under the events attribute.
Great. Okay, we've got a question about what if we have a model and dependencies that are larger than 1 gigabyte? How does EFS work through that? Is that okay?
I mean, Elastic File System is also a serverless service from AWS. So I think you could also upload like dependencies with the size of 2 gigabytes, but you have to be aware the biggest memory size of AWS Lambda function is only 3 gigabytes. So you cannot import models like with 4 or 5 gigabytes because they don't even fit in into memory. But sure, you can use like PyTorch with the additional dependencies with over 1 gigabyte. This will result into a longer mount time or loading time. But if you use events like SQS, I mean, only the first request will take like 35 to 40 seconds, and afterwards it's fast.
Yeah, do you have any tips on that sort of warm up? Back in the day, we used to just send requests to, so during deployment, we would just send a bunch of requests that would warm up these services. Does the API gateway do anything like that for us, or?
Yeah, currently I only know the same solution. In the serverless framework, we could add like an cron event here, which calls our serverless function like every 5 minutes. So we always have one concurrent function up and running. And otherwise, I don't know any solutions. If you have like mission critical APIs which have to respond in a second, I think this solution is currently not the best. Therefore, you can implement like a SageMaker solution or maybe a Fargate solution or something like that.
Gotcha. Gotcha. And we've got one more question, but real quick, I wanted to ask about GPUs. So can you tell us the Lambda GPU support? Have you tried it? Does it help? If Lambdas don't support GPUs, are we losing anything by serving them through Lambdas?
I don't know if, in my understanding, AWS Lambda don't have currently a GPU support. I hope it will come with re-event, fingers crossed. And the only disadvantage we have is like the inference of our model will take like 100 or 200 milliseconds longer. So a GPU would only be a performance increase in inference. Gotcha.
Oh, so it would take 100 milliseconds longer if you were going to use GPU?
No, it would be faster. I don't know the exact numbers, but I'm pretty sure it's faster, but I don't know how much it's faster. Right.
And you're doing PyTorch, right, in this one?
Yes.
Are you using, do you have like torch serve running or anything, or are you just passing it through like a Flask app?
No. When you create AWS Lambda function, you don't have to create like the Flask endpoint or torch serve. So you only implement like your handler function, which will be called with your event and your context when you call your endpoint.
Gotcha. One thing, me and Antje were trying to get your stuff to work, and we actually had a bug the first cut where we were always reloading the tokenizer in the handler. And just wanted to point that out, that obviously move as much out of the handler as possible, because you don't want to and it's cached and everything, I'm sure, but
yep.
Yeah, try to make that handler as thin as possible. Okay, there's a question. So Mario is asking, can we also use Kinesis for making predictions off a stream? Have you thought about that?
Yeah, sure. I think instead of adding or creating here an HTTP event, you can create like a Firehose event and then stream your data into your AWS Lambda function. It's like the same, you would build a normal Python function with Kinesis as entry point. You simply could use the solution at your Kinesis event and then implement it.
Gotcha. That's a supported configuration where you have Lambda trigger off a stream. I actually didn't even think about that. That's a huge benefit of serving these with Lambdas, is that then they can integrate in many different places. Awesome.
Yes.
Okay. Let's see if there's any other questions here. Is there any, so when you switch to use EFS, can you comment maybe on cost or said differently, what cost you are saving maybe by using EFS and not having to run your own network file system and all that stuff?
Compared to the first solution, I increased the cost, I would say, but I improved the performance. When you use Elastic File System, you have like the cost per gigabyte per month, and I use the burst mode. So you have like, I think 3.5 terabytes of data throughput. If you need like some provenized throughput, it would be very expensive. And you also you have to be aware, if you use the EFS solution, you have to add a VPC and subnet to your AWS Lambda function. Of course, you can use the default one, but if you want, if you run like say a secure environment or in a secure environment, you have additionally cost for your VPCs and for your Elastic File System, but they are compared to running on-demand EC2 instance like to zero. So they don't cost that much.
Sure. Excellent. Okay. Let's see if there's any other questions here. Yeah, great stuff. So just, fun conversation. I always like to get kind of silly towards the end here. What kind of bands do you listen to, Philip?
I like techno. So there are no bands, I would say, but I like the stuff from NTO and Joachim Pastor. It's like some more chilled music and nice to work and enjoy and relax.
Gotcha. Is that what you code to? You put the headphones on and you can code to that music?
Yeah.
Awesome.
Like 7 minutes long songs with no vocals.
Yeah, I'm a Grateful Dead coder, so I'll put Grateful Dead on, and it's 35-minute songs with lots of psychedelic lyrics. So awesome. Yes, Antje, don't you listen to some techno reggae craziness?
Oh, that's been many years ago. These days I enjoy chill music, Jack Johnson. And so,
yeah, you like sad love songs, like depressing love songs.
Only on rainy days, not for coding. No, great,
so what are you working
great
on?
session, Philip.
Yeah. So what are you working on next, Philip? What's going to be your next blog post? Are you thinking?
I want to work on some functional semantic search framework, which you can use in a Lambda environment. So I want to build separate models, which you can connect via SNS or SQS, where you can create like your own custom Google, I would say, in a serverless way. So you could search like a lot of PDFs, and afterwards you extract like a context and then could ask a direct question with like a mobile BERT implementation.
Nice. And a question about transformers. What were you doing before transformers came along? Or did you just always use transformers? Because that's changed our life. It's changed our book. It's changed everything.
Before transformers, I think I would say I used NLTK and Genism, so nothing special, deep learning or any deep learning methods.
Yeah, Jensen is a good one. How did you get into this space? Yeah, how did you get into natural language processing? What was interesting?
Like 1.5 years ago, I started to build or create or I had a startup idea with 5 friends where we want to implement a competitive or automatic competitive intelligence solution where we would use like public newspaper and articles. So I came into NLP, like where we want to extract informations from public data and analyze it and create like dashboards and reports for it.
Great. We've got a question here. Any recommendations to improve natural language processing in different languages beyond English? So you're a native German speaker. Yeah, any tips on non-English?
Yeah, I think you could implement like non-English models the same way as you do as English models. And on the Transformers Model Hub, there are like many non-English models, like for German, France, Spanish, Italian, Russian, or you could also use like multilingual model, which are getting pretty good results now. Or you could even train your own custom language model with using your Wikipedia in your language and some public book corpus or common web corpus, and yeah, create your own language model.
Cool. I'm posting a link to the Model Hub there. Yeah, the Hugging Face folks have really made it easy. And I know, folks like, I was speaking with LinkedIn last year, and they actually had to train their own BERT model from scratch, not because of like language purposes, but because of, like their specific domain, job listings, job titles, resumes, skill sets, didn't really transfer well from the generic BERT. So like, do you have an estimate of how long it would take and how many GPUs it would take to actually train like a Roberta model or a mobile BERT?
Oh, no, I'm not sure. It depends on how large your unlabeled text corpus is, and yeah, how big is your budget. I mean, you could trade like on 1,000 TPUs at the same time, then it would take like half an hour. Or you could use like Google Colab with your with 12-hour a day GPU. Probably would take like 2 to 3 months or 2 to 3 weeks.
For sure.
Okay. But you could also use like existing language models and fine tune them on your domain. So you could use like the German or English BERT and train or keep training it on unlabeled domain specific corpus, maybe for medical or physics or something like that.
What's your favorite BERT variant name? Like a funny name. Yeah, I like the Spanish Berto.
I find the France one pretty funny, the common BERT, because it's
common
like
BERT.
cheese.
Yeah, that's Ancha's favorite. Awesome. Hey, Philip, thanks so much for your time, buddy.
Thank you too. It was a pleasure.
Yeah, thanks for being an American football fan. Yeah, go Bears. The Chicago Bears.
Saints.
Oh, the Saints? Yeah,
yes.
You're a Saints fan?
Yes.
Yeah, Drew Brees got knocked out pretty good last night. Got some rib injury going on.
Yeah, hope the best.
Yeah, Ancha, anything else from you? Any questions?
No, everyone, yeah, Chris posted the link to the Hugging Face models in the Slack channel, so not here in the actual Zoom chat. So hop over to the Slack channel and you will find all the links. I also posted Philip's GitHub repo there again. So if you want to have a look at that great session, feel free. Thanks so much, Philip. Really enjoyed the talk. Yeah.
Yeah, and if you have any questions left, or maybe when you implement the solution and there's a problem or an issue, reach out to me over Twitter or LinkedIn. I hope I can help you then.
Awesome, Philip. Yeah, we'll talk to you soon, buddy. Maybe we can meet in person. Yeah, I'm in Germany quite a bit during normal times.
Nice.
All right, buddy. See ya. Bye, everyone.
Bye.
Bye, everyone.